Hi everyone, I hope you're all well. Today we're going looking at work done and we're going to just explain what is meant by that. So before we get started, do the usual, find yourself a quiet space to work, get yourself a pen, piece of paper and a calculator. Today would help you a lot as we will be doing a few calculations. Once you're all settled, write down today's LO and today's date. It might not be the 20th of September, so do change it to your current date. Pause the video while you do all that, and once you're ready to go, press play again. Okay, so let's start with our retrieval practice. So you will need to pause the video. You've got 5 questions to do there. The 5th question is a mix and match. So you've got the pictures correspond to the letters A, B, C, D, and E. Again, pause your video, give yourself a couple of minutes to do this, and press play once you're ready to go through the answers. All right, so question 1, what is meant by the law of conservation? That is energy that can be transferred usefully, stored, or dissipated, but it cannot be created or destroyed. So you can see that's your first answer there. What is a system? It is an object or a group of objects. What is a closed system? It is where no energy can enter or leave the system. For question 4, a pendulum swings in 5 stages. List the 5 stages to go with the diagram. We're talking about this diagram over here. So you've got maximum GPE of the mass at stage 1. At stage 2, the GPE is transferred to kinetic energy. At stage 3, you've got maximum kinetic energy of the mass. At stage 4, your kinetic energy is transferred to GPE. And at stage 5, your maximum gravitational potential energy of the mass. And finally, question 5, the diagram shows the stages in a bungee jump. Draw a line from each letter to the correct description and then the correct energy change. So for picture A here, we've got our little man standing on a board. So the bungee jumper has not yet jumped. Sorry, and I'm waiting for that screen to go down. And then that corresponds to all the energy in the system is in the gravitational potential energy store. For picture B, we have got our bungee jumper has just jumped. So that's the bungee jumper is falling and the gravitational potential energy store is being transferred to kinetic energy. For picture C, the bungee cord is just becoming taut. So remember, taut means it's just before it's about to stretch. It's been pulled out to its full length. And the energy is a combination of gravitational potential energy and kinetic energy. For D, you've actually got the bungee cord is stretching, and this is GPE and kinetic energy are transferring to elastic potential energy. And lastly, picture E, the bungee cord is recoiling, and that's your elastic potential energy is going back to kinetic and gravitational potential energy. So you might want to pause the video now and just give yourself a chance to go through all of that and make sure you got it right. Okay, so what we're looking at today, what is meant by work done, and we want to calculate work done by a force acting on an object. So what actually is work? What comes to your mind when you think of the word work? So in the very first lesson, actually, we said that energy was when the ability to do work. So what do you think work is? So the definition, again, green box, write it down, it's a definition. The definition of work is done whenever energy is transferred from one store to another. So remember we said energy is the ability to do work, so that makes sense. Work done is when energy is transferred, when energy is changed from one type to another. So we've got 2 main types. We've got mechanical and we've got electrical. In our first lesson, we listed 4 types that we could do that, but today we're just looking at our 2 main ones. So mechanical, where a force to move an object, and electrical, that current that transfers energy. So if you've not got your definition down, pause the video and write it down now. Okay, so that's just your picture of your two main types. So you should now be able to describe what is work done. That's it. That is your definition. That is all you need to know to do that. So what we're going to do is it's more likely that you will get calculations on work done in your exam. So we're going to look at a few examples of how we would calculate work done. So how do we know work is being done in the first place? If we look at this picture, we've got a dog. He's attached to a rope and he's pulling a sleigh. And there is a force being applied to the sleigh which is causing it to move. So if we look at the dog has chemical energy in his muscles, in his cells. He starts walking. That means he changes that chemical energy into kinetic energy. That kinetic energy is stored in the moving sleigh. And as the sleigh moves, there's a little bit of friction. So thermal energy store in the sleigh and the ground starts to build up. So is work done? Do you see work being done here? So the dog applies the force to the sleigh. That force causes the sleigh to move. This shows energy transfer. Okay, so we can see that we start with chemical in the dog. By him moving, that chemical energy changes to kinetic energy, and then that kinetic energy that causes our sleigh to move changes to thermal energy because of the friction between the sleigh and the ground. So yes, work is done. We can see that. We can see a change in energy. So we actually have an equation for this. So again, we need to learn this equation off by heart. It's one of the 21 equations we have to know for physics. So it is really important that you write this down. It's a simple equation. Work done is equal to force times distance. If we think about this logically, that makes sense. If work is energy changing or energy transferring, then how do I see that? Well, I can see work being done by the amount of force I put on an object to move it. And the amount of force I apply to the object, I can see by the distance that I travel. So in this example here, if I was trying to calculate the work that the dog did on the sleigh, I would multiply the force he applied to the sleigh, which was 50 newtons, by the distance he managed to move that sleigh, which was 3 meters. So 50 by 3, 150 Newton meters, which actually we often just say as joules. So force, we use the symbol F and we measure that in newtons. Distance, we use the symbol S and we measure it in meters. Work done, we use the symbol W and we measure it in joules, or as we said, Newton meters, which makes sense because we're multiplying newtons by meters. So make sure you've got that down before you move on. Okay, so work done is basically just equal to the energy transferred. So we can easily say in our equations that how much energy is transferred tells me how much work is done. And that's why I can measure work done in joules. So again, you've just got your triangle there. For those of you that like to work with a triangle, you have work on the top of your triangle and then the divide line, and on the bottom, force multiplied by distance. For anyone that just likes to learn the equations off, you can see there you've got force is equal to work done divided by distance, and likewise distance is equal to work done divided by force. Again, you need to learn this off. It will not be given to you in the exam. So let's try an example together and then I'll give you a few examples to try by yourself. So this first one, a cyclist pedals a bike with a force of 1,000 newtons and it moves 250 meters. So how much work has been done by the cyclist? Write down my equation. Work is equal to force by distance. So that's 1,000 by 250. That's 250,000 joules. I can, and we would have talked about this before, I can convert my joules into kilojoules. So to convert joules into kilojoules, all I've done is divide by 1,000. So everywhere you see that K, it just means that that number has been multiplied by 1,000, okay? So try and do this one yourself. I actually did it for you a few minutes ago, but if you want to pause the video and try and do it yourself. Okay, so hopefully you've wrote down work done is force times distance. So that's 50, the force of the dog, multiplied by the 3 meters the sleigh moved. So 150 joules. Nice simple one. All right, so 150 joules. This tells us that basically there was 150 joules converted from the chemical energy stored in the dog to the kinetic energy of the sleigh. So we know that all that energy in the dog was changed over to kinetic energy. This car is traveling at a speed of 20 meters per second. Okay, be careful now. We've been talking about work done. We've been using meters and we've been using newtons. So now we're looking at a car. We know its speed is 20 meters per second. The driver applies the brakes and the car comes to a stop. How does that happen? What has the car done? What has the driver done to stop the car from moving? So remember, car's moving, so therefore that means it's got kinetic energy because kinetic energy is moving energy. So when the driver presses on the brakes, what actually happens is the brakes press against the wheel of the car. So they come down and they press against the car. That causes friction between the brake and the wheel. And what we know about friction is that friction actually can convert energy into thermal energy. So we take our kinetic energy, so remember our wheels are moving, so they're going around, they've got kinetic energy, and we transfer that to thermal energy in the brakes. The temperature of the brakes is going to increase, and that actually in turn slows down and stops the car. So, looking at this question, I want you to pause your video and try and answer this question. So, during braking, a force of 2,000 newtons is applied to the brakes of a car. The car takes 20 meters to come to a stop. Calculate the work done. Pause the video now and give yourself a minute to do that. Okay, so hopefully you've done 2,000 newtons multiplied by 20 meters, and that gives you 40,000 joules. Again, we could have said 40 kilojoules if we divide by 1,000. So a car engine moves a car with a force of 10 kilonewtons, and it does 500 kilojoules of work. How far has the car traveled? So we need to be really careful here. We'll walk through this one together. They've given me newtons and they've given me joules, but they've actually got the K in front of them for kilo. And what did we say kilo means? It means by 100. So the first thing I need to do is 1, write down my equation. 2, I need to rearrange it because they've asked me for distance in this one. So distance is equal to work done divided by force. And then I'm going to convert my work and my force back into newtons and joules. So we cannot calculate these if we leave them in kilos. We have to convert them back. So I convert back my 500 kilojoules into 500,000 joules, and I convert my 10 kilonewtons into 10,000 newtons. So all I've done is wherever I see a K, I take that out and I multiply by 1,000. Take that out, multiply by 1,000. And I pop all that in the calculator, I get 50 meters. Okay, so now you should be able to calculate work done by force acting on the object. And again, here are some useful links to help you that will have more questions on them. So you've got free science lessons, You've got BBC Bite Size and Pass My Exams again, all really good resources with loads of links for you to use. Next lesson, we're going to start looking at each of the individual energy types. The first one will be kinetic energy. And remember, send me an email if you need help with anything at all. Hope you have a lovely day and we'll talk soon.